Welcome back again to the channel. Let's continue with problem number 7. Show that this guy, -1 plus square root of 3i, all divided by 2, is a cube root of 1. Okay, so what does it mean to be a cube root of 1? It means that this guy is a solution to x cubed minus 1 equal to 0, or x cubed equals to 1, right? So then how we answer for this problem, it is simply by verifying that when we substitute alpha for x, we get exactly 1. Or in other words, we just need to multiply alpha by itself 3 times and verify that it is indeed equal to 1. Okay, so let's do it. So problem number 7. So what is alpha? -1 plus square root of 3i. Let alpha be -1 plus square root of 3i divided by 2. Okay. So to make it less messy, we can write down twice of alpha is equal to -1 plus square root of 3i, right? So it follows then 4 alpha squared is equal to -1 plus square root of 3i times, or let's do it, 8 alpha cubed, which is 2 alpha cubed, is equal to -1 plus square root of 3i cubed. So let's multiply the first 2 copies of -1 plus square root of 3i. This is equal to -1 times -1 is 1. Square root of 3i times square root of 3i will be -3. And then we have 2 times this times that, -2 square root of 3i. So let's simplify. This is equal to -2 square root of 3i, -1 plus square root of 3i. So let's factor out the -2, 1 plus square root of 3i, and we can, okay. So this looks like the product of 2 expression a plus b times a minus b. So let's rearrange the expression to make it looks like that. So what do I mean? What I meant before was to rewrite this as square root of 3i plus 1, and the other one as square root of 3i minus 1. So let's see. We can see that this is of the type a plus b times a minus b, and we know how to simplify those kind of product. So -2 square root of 3i times square root of 3i is going to be -3 minus 1 times -1. 1 times 1. So -2 times -3, -4 is equal to 8. So 8 alpha cubed is equal to 8. Therefore, alpha cubed is equal to 1, and hence alpha is a cubed root of 1. Okay, so not that hard, right? Okay, so that's all for this video. See you again on the next problem. Don't go anywhere.